So, without further ado, we're going to go ahead. So, a lot of, for many, many years, particularly in this country and in Western culture, bats have had a bad rap. And a lot of people still think that, most bats have rabies. They do not. They have the same incidence of rabies as any mammal. It's about 0.5% in the natural population. They get tangled up in your hair. Well, people are afraid of bats, but it's because of the culture that we've brought up in. And in some parts of the world, like China, the emperors always had bats embroidered on the outsides of their robes. And if you look at a lot of the Chinese china, stoneware or porcelain, and I have a couple of sets that have little bats on the edge of them. They're stylized, but if you look carefully, they have bats which symbolized longevity and good health and prosperity. So I want to go through, and we're going to talk a lot about really bats that you might find along the Coyote Creek. Now, when I grew up, I thought of bats as these black things that, just sort of, flew around in the sky. I did not know much about them, but, I just knew that, we didn't know a lot about them, but they're all dark or black. And when I started studying bats, I thought, wow, the diversity is amazing. So I took this picture in Costa Rica some years ago, and it's a tent making bat. It hangs from a leaf of a heliconia like a banana leaf. And it was sleeping. And then I looked up and I took a picture of it. It woke up and it just looked straight at me. And I looked straight back and I got a couple more pictures. And then I left and it went back to sleep. But there are now over 1,500 species of bats that are recognized by science. And we are finding new species every year. So I want to take you through just some of the diversity, some of the things that bats eat, and then we're going to concentrate on some of our local bats here. There are no bats that are blind. Even this bat, which has very tiny eyes, this is a horseshoe bat, and yes, it hunts primarily through echolocation. It uses its large ears. It probably doesn't have very good vision, but in fact, it does see. And some bats have very, very large eyes, and big noses and small ears. This is one of the flying foxes or pteropods. It's an epauletted bat from Africa, and it finds its fruit primarily by what? Smell, of course, like a dog, and it's often hunting for its fruit in the early evening. So it's crepuscular, meaning that it uses the twilight. The largest bat in the world is the gigantic flying fox from northern India. It has a wingspan of about 2 meters, or really probably closer to 6 feet. And this is, again, another tropid. It does not echolocate. It has small ears, does not have a tail. And the tropids, or the flying foxes, which is a separate suborder, has a small nails on its fingers. So most bats just have a nail on their thumb. But the tropids also have this little nail on their index finger. So bats are basically flying with their hands. And chiroptera means chiro, as in chiropractor, someone who practices medicine with their hands. And ptera, we all think of the pterosaurus or pteranodon flying lizard. So bats' scientific name, Chiroptera, is really flying hand. Okay, and some bats are just incredibly beautiful. I mean, in terms of their complexity. So this is a wrinkled face bat. It's a very interesting bat because it will fold its wing up over its head when it's disturbed or when it doesn't want to be found. And the wing is so thin and transparent that it can probably see motion, but there's no eye shine, which is really important if you want to evade predation. And for years, scientists have contemplated, debated, discussed why they don't have any fur on their face. This is the eye, by the way. Their nose is down here, the mouth below that. And this is the bottom of their ears. That's the little pinnae right there. I mean, the tragus. The pinnae is the fleshy part of the ear. So we think that it's probably because they put their heads in very fresh fruit and it's gooey and gunky, just as a vulture might do that in a carcass. But the vulture is, in gunky flesh, whereas this bat is probably in gunky fruit. The bats that we have here in the Bay Area are all insectivorous, as this spear-nosed bat is. And this is a yellow-shouldered bat, Stenira lilium, but the neat thing about this picture is you can see on the top of the head there, the pistil, the female part of the flower. And it already has pollen on the head. So when it's visiting this ocotillo flower, then it's actually pollinating flower by flower and presumably plant to plant. And here's another yellow-shouldered bat. It's pollinating this banana. I'm going to go right back to this for a second. Excuse me. The very cool thing is that the banana plant has bracts, and these bracts open up to perfect parabolic mirror-like shapes that make a hot spot when the bat is echolocating. So the bat echolocates into the banana, and when that bract is perfectly shaped and it makes a big white spot in terms of a echolocation response, the nectar is flowing and the pollen is ready to be picked up by the bat. And some bats, like this Stracops, is eating a frog. The frog, that's a male frog. When it calls, it doesn't know it's also alerting the fact that it's, in a position where one of these frog-eating bats can take it. I've studied fishing bats in both Mexico and Belize and Costa Rica. This is the greater bulldog bat, and it has claws or talons that are about a centimeter long, razor sharp, and it simply glides those through the water after it detects a small amount of disturbance in the water. And finally, this is the greater false vampire or Vampirum spectrum, and it's simply yawning. But the head is about the size of a fox. It's the largest New World bat, and it has a wingspan of about 3 feet, and it is a serious carnivore. I mean, it'll take out chickens, rats, other bats, and so on. And you can think of them as sort of the mountain lions of the bat community. Okay, a little bit about sonar. So we could spend a long time just on sonar, and it's one of the nice things you can do at night in the field. with any number of instruments, some more expensive than others. I think for a couple $100 now you can get a little attachment to your phone from Wildlife Acoustics. And it is not very accurate at determining what bat you're hearing, but the microphone is good, and you can use other programs to do a little better job of identifying the bat. But here the bat is putting out a high frequency sound. It comes out, it hits, this is a spingid or hawk moth, and then it comes back, a small amount of that bounces back, hence the name echolocation. It's locating by the echo. Now, this is so intense that if you had a smoke detector alarm 1 inch from your ear, that would be about the same volume of sound, the same decibels, which would be deafening. And over time, you would probably go deaf. So what the bat does, which is like this amazing evolutionary development, the bones in the inner ear disarticulate. They actually come apart so that there's no noise that or sound that is received by the bat the instant the sound goes out. So the bones disarticulate and the sound goes out, then the bones come back together and it hears the sound. And, you know, bats are doing this like in milliseconds a time. And so, you know, it's a really rapid, very rapid movement. Okay, whoops. Okay, so I want to talk about our own bats here along Coyote Creek. And the two most common bats that we have are the Mexican free-tailed bats and the Eumamyotis. And many of the other species are in decline, and I would say all the other species we have in California are in decline, but these two are on the increase, and I will show you why. One of the things that I believe has increased both species is that when we built buildings, this is the Mission Dolores, 1776 in San Francisco, and they use tile roofs. Tile roofs make great crevices. They warm up during the day. They stay warm through the night. Perfect place to raise young. Another thing that we've done is at metropolitan areas, we've built huge dams and reservoirs. The dams have acted as sites where a lot of bats can roost during the day, and the reservoirs have greatly increased the foraging habitat of both those species. In fact, the Eumamyotis has specialized on flat water habitat, and we have so much more of that today than we used to pre-European colonization. So what does urbanization do? Besides increasing those two species because we have more habitat, most of the other species have declined, particularly as a result of urbanization, noise pollution, light pollution, and probably most significantly, habitat conversion and destruction. So I listed here the bats that you now find in Marin County, which still has some wild areas, 13 species. If you go into the virtually totally urbanized San Francisco County, only 4 species of bats, and of these, primarily only the first 2, western red bat and little brown bat, come through the area, but only as migrants. Okay, a little bit more about Eumamyotis. I want to tell you where you can find them. They forage not only on flat water all along Coyote Creek, but also in the South Bay. I had a graduate student put out bat detectors for her master's over much of the saline and brackish water, and they regularly forage over insects that tolerate brackish water. And they also go over pure marine areas where you have flying insects. But they're primarily a emergent aquatic insect forager. So when you go out and you see a bat fairly small, flapping pretty hard, that's almost always a Eumamyotis if it's flying along the water. The Brazilian free-tailed bat, or as we sometimes call it, the Mexican free-tailed bat here, because that's the subspecies for Western North America. They fly much, much faster. They have a low, if you're using your bat detector, they have a very low echolocation of around 20 to 30 kilohertz, whereas Eumamyotis is at 50. But these are amazingly eclectic and flexible in terms of what they eat and where they go. So they follow moth migrations in California as they move north, and they are found in every one of our habitats and up to about 10,000 feet. So I want to show you a couple of videos. This is of a cave in Texas. Whoops. This worked before. There we go. Just amazing. So at this particular cave, there are over a couple million bats emerging. The closest thing that we have here is Yolo Bypass. I think it probably has about 250,000. And I have been counting the Franklin Boulevard Bridge bats for 15 years now. And they're about 160,000. Okay, I'm going to do this one. When I show this to kids, I ask them to count the bats. And then they say that you can't do that. And I say, okay, well, then we'll just slow it down for you. And it's going to slow down here. There we go. Now count the bats. We have video equipment now that can make a polygon around each one of these images. And as it separates from another image, it will count the bat. But we don't do it long ways. We do it on the side. And it's probably as accurate as trying to count them just by our own eyes. Okay, I have caught the hoary bat both along Lower Coyote Creek and then in Penitentiary Creek. And this bat is found throughout North America. It is an incredible flyer. For about 10 years, I worked on the Hawaiian hoary bat, which is sister taxa to this, or taxon to the mainland hoary bat. But they are, I think, in serious trouble because of the wind energy turbines. And there are at least 7 hypotheses why they get hit. But for a number of reasons, they are probably attracted to wind turbines. And we're still trying to figure out exactly why and how we can reduce that. There are things that we've done that will reduce it a little bit, like broadband high frequency sounds, UV lights. But in the end, we're still killing a lot of hoary bats, which is just awful. So they are solitary bats. They roost in foliage. They don't roost in crevices. And they're solitary. They'll have 2 young every year. But they can fly probably 60 miles an hour. At least that's what we found in Hawaii. Okay,
Dave,
yes.
you've got just a couple more minutes, so we have time for Q&A.
Okay, very quickly, one of my favorite bats, Western red bat. And they have an interesting seasonal currents. So I'm going to just go through. This is the male summer range. They migrate in the winter. They occur just in the core of the Central Valley and on the coast. Finally, California migrants, which you will see throughout the Coyote Creek chain. And it forages about a foot away from coast live oaks and other oaks. So it has the same frequency as a Eumamodus, but the best way to separate it is to just look at it foraging. It does not forage over the water. It forages, again, over vegetation about a foot away. Big brown bat are common throughout North America in houses, although they are slowly being extirpated from all our urban areas. I have caught some Townsend's bigger bats in various parts of Coyote Creek. They're cavernous roosters, so they need a cave. An old barn that's not being used, even an attic in a house, is perfect for them. And then finally, probably my favorite bat, pallid bat, which we made into a California official state bat. Took me 7 years to do that. And in the end, with the help of a 12-year-old. But this bat is, really amazing. It eats prey off the ground. It doesn't echolocate to find its food. It listens passively, and it can hear a cricket walk on the ground. I started the bat business by observing pallid bats that were picking up slugs, and I figured out that they located them by the slug eating vegetation with their radula, which makes a little sound. They occur right through the winter. We won't spend much time on this. I'm going to show you this video. So lately, I've been working with a group in Israel and Germany on GPS data logging, and we're learning a lot more about the species. So we put a GPS data logger on its back. It also has a microphone on it. It's going to take off here. We're almost done, Marav. And so this is a recording that we got from one bat, presumably communicating to another bat and probably its young. And then this is the kind of spatial data that we're collecting. This is just one bat. Each one of those dots is about 1 minute apart. So it spent a lot of time in this bottom left corner. And this is some work that I did, now maybe 8 years ago on the Mexican fishing bat. Each one of those tiny circles is 1 minute apart. And some of these bats would go as much as 100 miles in a night. So it's foraging over the water. Ecologically, it's a storm petrel.